Hi everyone. So this is a continuation of our first lecture video about logarithmic equation. So for this lecture video, we are going to discuss about the logarithmic inequality. So for the definition, the logarithmic inequality is an inequality that involves logarithm. Now we already mentioned this that in logarithmic inequalities, we use the symbols greater than, less than, greater than or equal to, or less than or equal to. Now let us discuss the properties of logarithmic inequalities. So for the first one, given the logarithmic expression, the logarithm of x with base b, 1, if b is greater than 0 but less than 1, then x sub 1 is less than x sub 2 if and only if the logarithm of x sub 1 with base b is greater than the logarithm of x sub 2 with base b. Number 2, if b is greater than 1, then x sub 1 is less than x sub 2 if and only if the logarithm of x sub 1 with base b is less than the logarithm of x sub 2 with base b. Okay, so to apply the properties of these logarithmic inequalities, let's try to solve the following logarithmic inequalities. So we have four. So we have two things to remember when solving logarithmic inequality. So the first one, the direction of the inequality less than or greater than is based on whether the base b is greater than or less than 1. The second one, check the resulting x values so that the logarithms are defined. Okay, so we have to check the x values just like what we did in the logarithmic equation. We are going to verify the values of x. And also to add, the direction of the inequality changes whenever we divide both sides of the inequality by a negative sign. Okay, so let's try number one. So for number one, we have the logarithm of 2x minus 4 with base 2 less than or equal to 5. Now, in this case, as compared to the logarithmic equation, we cannot simply transform this inequality to um, exponential equation. Okay, so we have to use the property number 4. Okay, the property number 4, let us write it down. Property number 4 says that if x is greater than 0, then b raised to the logarithm of x with base b is equal to x. Therefore, x is equal to x. Okay, so for the solution, applying this property, okay, the solution, okay, we can rewrite this one as logarithm of 2x minus 4 with base 2 less than or equal to 5 can be written as 2 raised to the logarithm of 2 with the logarithm of 2x minus 4 with base 2 less than or equal to 2 raised to 5. Okay, so whatever we did on the left side part, we will do it also on the right portion. Now, by property number 4, we can cancel this out. So, we can now get the inequality, which is the 2x minus 4 less than or equal to 2 raised to 5. Okay, so simplifying this inequality, 2 raised to 5 is equal to 32. Okay, so 2x minus 4. Combining similar terms, so we have 2x less than or equal to 32 plus 4. So we will get an answer of 36. Okay, 2x is less than or equal to 36. Divide both sides by 2. Okay, so we got an x of less than or equal to 18. Okay, now we have to check this part if this is greater than 0. Okay, so to do that, we have to do it separately. So we have to check if that is greater than 0. So 2x minus 4 greater than 0. So transpose negative 4, we have 2x greater than positive 4. So divide both sides by 2. We will get an x that is greater than 2. Now, we can now solve for the solution set of this logarithmic inequality. So to do that, we have to plot the values using the number line and then get its intersection. Now we are going to just approximate because 2 is away from 18. Okay, so imagine the number line. So let's say, let's start from 0. Okay, so this is 0, 1, 2, 3, up to 18. Okay, up to 18. Okay, so this is just an approximate. So if we are going to plot x is less than or equal to 18, take note that the inequality is less than or equal to 18. So that means that we include 18 as the solution. So if we're going to do that, we are going to make a circle. Sorry for that. Ayan. And then, the values that is less than 18 are to the left. To the left. Okay. And then, if we're going to plot x greater than 2, okay, x is only greater than 2. So we do not have the equal, greater than or equal to. So that means that it is a hollow circle. And when we say greater than 2, so that means that it is going to the right. Going to the right. Okay? So if we're going to get the intersection of these two, that means that the solution set for this one, for this logarithmic inequality, will be 2, not included, and up to 18 included. Okay, so that will be the solution for this logarithmic inequality. Now, let's try another example. So we have number 2, the logarithm of 2x minus 4 with a base 2 greater than the logarithm of 4x minus 10 with a base 2. Okay, so let's try this one. So we can apply the property that we had. So since both of the logarithms has the same base, so we can now write 2x minus 4 and 4x minus 10. Okay, so 2x minus 4 greater than 4x minus 10. Okay, so we can now combine similar terms. So 2x minus 4x greater than transpose negative 4. So this will become positive 4. So this is negative 10 plus 4. Okay, so solving 2x minus 4x is negative 2x greater than negative 10 plus 4 is negative 6. Dividing both sides by negative 2. Take note that we have to change the sign since we are dividing negative 2 both sides. So cancel this out. X less than um, negative 6 divided by negative 2 is positive 3. Okay, so this same with what we did, we are going to check these two if they are greater than 0. Okay, so that is by definition. So let us check 2x minus 4 greater than 0. So transpose 2x greater than transpose 4. So this will become positive divided by 2 both sides. X is greater than 2. Okay, next one, we have 4x minus 10 greater than 0. So 4x greater than transpose 10. So this will become positive 10. Divide both sides by 4. So we have an x that is greater than 5/2. Okay, so using the number line, we will plot again the x values that we got. So this is 0, 1, -1, -2, this is 2, and this is 3. Okay, so if x is greater than 2, okay, this is 2, so greater than 2 is going to the right. X is less than 3. Okay, x is less than 3, so this will be going to the left. And then x is greater than 5/2. Now, we know that fractions can be converted to decimal. So, 5 divided by 2 is equivalent to 2.5. So, 2.5 is somewhere here. Okay, somewhere in between 2 and 3. Okay, okay, so somewhere between 2 and 3 and going to the right. Okay, so we are now going to get the intersection of these three. So as you can see, the intersection of these three can be found somewhere in between here in this portion. Now, we can say that the solution set for this logarithmic inequality will be 5/2, starting from 5/2, 5/2 not included, and then 3 up to number 3 not included. Okay, since that is the intersection of these three. Okay, so we're done with number 2. Let's proceed with number 3. Now, in this case, we have the logarithm of x cubed with base 2 greater than or equal to 18. Now, in this case, we can also apply the property number 4. So, we are going to write it again as 2 since we have base 2 so that we can cancel out the logarithm. So 2 raised to the logarithm of x cubed with base 2 is greater than or equal to 2 raised to 18. So we can now cancel this 2. So um, x raised to 3 will remain greater than or equal to 2 raised to 18. Okay, so 2 raised to 18, we can solve that using our calculator. So 2 raised to 18 is equivalent to 200, 262,144. So 262,144. Now, to remove the cube here, we have to cube root both sides for us to get the value of x. Okay, the same with what we are doing with um, square root. So we square both sides to remove the square root. Okay, so to remove the cube here, we have to do the cube root. Okay, we have to get the cube root of both sides. Now, using our calculator, getting the cube root of 262,144, we will get an x value that is greater than or equal to 60, 64. Therefore, the solution set for this problem will be 64, 64 included to positive infinity since the inequality sign here is greater than or equal to 64. So greater than x will be positive, positive infinity. Okay? Next example, so we have the logarithm of 2 with base 5 less than the logarithm of 4 with base 5 plus the logarithm of 3x minus 1 with base 5. Okay, so applying the same property and laws. So we can rewrite this one since this is addition. So this is addition. So that means that we can multiply 4 and 3x minus 1. So we can rewrite this as the logarithm of 2 with base 5 less than the logarithm of 4 times 3x minus 1 with base 5. Okay, so simplifying this um, logarithm, so we can distribute this one. So we have the logarithm of 5 with logarithm of 2 rather with base 5 less than the logarithm of 4 times 3x will be 12x minus 4 with base 5. Okay, so since both of this inequality has the same base, so they have logarithm of 2 with base 5, logarithm of 12x minus 4 with base 5, so we can now solve, okay, for the value of x. So 2 is less than 12x minus 4. So solving for the value of x, we can transpose or combine similar terms. So we have 12x, negative 12x less than transpose 2. So we have negative 2. So this will become negative 12x less than negative 6. So divide both sides by 12, negative 12. So this will be cancelled out. So we have, since again we divided both sides by negative numbers, so the sign will change. So x will become, the inequality will become greater than positive 1 half. Okay, since negative divided by negative is positive. Okay, so we have an x that is greater than 1 half. Now, by definition again, we have to check this one if that is greater than 0. So we can do it separately. So 12x minus 4 greater than 0. So 12x greater than transpose 4. So this will become positive. Divide both sides by 12. So x is greater than 1/3. Okay, so plotting it using the number line. So let's plot the x values that we got. Okay, so let's start with 0, 1, 2, and 3. Okay, so let's try to approximate. X is greater than 1/2. So that means 1/2 is not included since this is not greater than or equal to. So the inequality here is only greater than. So greater than 1/2 is somewhere in between 0 and 1. So going to the right. Okay. And then 1/3. Okay, if you are not sure as to where is 1/3, you can convert it to decimal. Now 1/3 is 0.3. Okay, 0.3. So somewhere here, somewhere before zero point 0.5. Okay, so zero point 0.3 is somewhere here. And sorry for that. So going to the right as well. Okay? So getting the intersection of these two. Okay, so it is very small lang yung gap nila. So we can say that the solution set for this problem will be from 1/3 to 1/2 not included. Okay, so this is how we solve the logarithmic inequality. Okay, so good job everyone. So let's go back to our objectives. So at the end of the video, the learners are expected to first distinguish between logarithmic functions, logarithmic equations, and logarithmic inequalities. Two, illustrate loss of logarithm, and lastly, we're able to solve logarithmic equations and inequalities. Thank you so much.